Hello, welcome to week 5's discussion about derivatives, more specifically the MyMathLab homework and the way that they ask questions. So in the lecture we did the secant line. Right here they're saying that the function is 3x squared. Oh, forgot to introduce. This is question number 3. And then they say here's the point 2 and f of 2. So for 2 and f of 2, so that means substitute a 2 into the function. So f of 2 means take 3x squared, or 3 times 2 squared, and then that equals 3 times 4, and 3 times 4 is going to be a 12. So find the slope of the secant line through this point and then this point. So what they're saying is, this is the second point. This is the first point. And now find slope. So for slope, you subtract the two y values. So this is y2. So they're saying that's f of 2 plus h minus the other y value, which is this f of 2, which I went ahead and figured out. That equals a 12. And then on the bottom, we will have x2. So that's the 2 plus h. And then minus the other x value, which is a 2. Okay, so that's the setup. Now actually simplify this. So this part means take 2 plus h, put that in there, so I'll have 3, and then replace the x with 2 plus h. So we'll have 3, and then 2 plus h is squared, minus a 12, so there's the top. And then on the bottom, this 2 and this minus 2 are going to cancel, so there's only a h on the top. And then we need to do algebra. So squaring 2 plus h. So when you have a binomial squared, so bi means 2. So if you have a binomial squared, you could go ahead and put a plus b times another a plus b. But we do this so often, there's actually a shortcut. So you would go ahead and distribute, and you would get a squared. Then you would distribute, and you would get plus ab. Then distribute the b, and you would get plus ba or ab. They mean the same thing. And then you'd get plus b squared. Or in other words, you would get a squared. In the middle, there would be 2ab, and then plus b squared. So whenever you have a binomial squared, you could go through these steps each time, or you could just remember that would be the shortcut. And that's what I like to do. So I'm going to use that shortcut. So the 3 is in the front. I'm not messing with the 3 right now, but my shortcut formula says square the 2, so that's going to be 2 squared is 4. Then multiply these 2, which is 2h, and then double the answer. So that's what this part was saying. Multiply the two things, and then double that answer. So if you multiply the 2, that's going to be 2h. Double it, that's 4h. And then the h gets squared. And then just recopy the minus 12 and the divided by h. And then distribute the 3. So when I do that, I would get 3 times 4 is 12. Then this is going to be plus 12h. And then this is going to be plus 3h squared. then copy down the minus 12 and divide it by h. And then there's a little more simplifying we could do. The negative 12 and the positive 12 will cancel. After that, this has an h, and this has an h, and this has an h. So I can actually cancel one h in each place. So this one is going to leave one h behind, but everything else, all the other h's got canceled. So that means all that's left is this 12 plus 3h. So that is part A. Then in part B, so find the slope of the secant line through that. Okay, we're done. Next, find the slope of the graph at that point. Well, that is just saying take the derivative, and you could either do the power rule, or since we've gone this far, then all you do is take the limit as h goes to 0. This would be 3 times 0. That means the answer is 12. So that's the slope at that particular point. Or hopefully you already watched the lecture and you now know the shortcut, the power rule, and you could just go the derivative is going to be take the 2, bring it in front, and multiply with the 3. So 2 times 3 is 6. And then subtract 1 from the exponent, which is going to leave x to the 1, or just x. So we have this. And then they said use that x is 2. So plug in a 2. And the answer is the same. I still get 12. Of course, this way was a lot more fun, but the power rule is much faster. And then find the equation of the tangent line. So I did that several times in the lecture part. Let's look at something else from the homework. Question number 5. So it says x to the 4th. And if you watch the lecture, the very last one I did was the instantaneous rate of change. So that's saying find the derivative. Oh, actually, they say it's known to be 4. Oh, I thought we were going to find it. They actually told us. So they're saying that the derivative equals 4. So the derivative, if you plug in x equals 1, it equals a 4. And then find the equation of the tangent line at that point when the x is a 1. So in other words, at the point when x equals 1, and then we have to find out what y equals. Well, if you just take that x equals 1 and plug it in right here, it's going to be 1 to the 4th. And 1 times 1 times 1 times 1 is 1. And then find the equation of the tangent line. So that goes y minus the y value of 1 equals the slope times x minus the x value, which is 1. And then on the right side, distribute. Looks like I switched my red and my black pen. So on the right side, when you distribute, that's going to be 4x minus 4. And then just add 1 to both sides. And I end up with y equals of 4x, and a negative 4 and a positive 1 is minus 3. So find the equation of the tangent line. The equation of the tangent line is, so you just type in the answer right there, y equals that. Type an equation. So in other words, make sure you put the y equals. Don't just put this part, but they're saying put the whole thing. Y equals that. Use integers or fractions for the numbers. So integers means whole numbers. There we go. Bob is your uncle. All right. Then, oh look, on this one, I even put a reminder to myself. So question number 7, when they say the 4-step process, most people don't call it the 4-step process, but that's where we use the definition of the derivative with the limits and do all that extra algebra fun. So with this one, the function is x squared plus 9x minus 6. If we were allowed to use the power rule, I would say the derivative is 2x plus 9, and I'm done. But with the definition of the derivative, it's going to go take the limit as x approaches a and use this definition right here. So that's going to go f of x minus f of a over x minus a. And this one, it's saying that your variable is going to be x. So when we're done, our variable needs to be x. And then later, after we do the first one, later plug in x equals 1, x equals 2x, but that goes later. So for this one, it's going to be the limit as x approaches a. First, I need to copy and paste the function right here, x squared plus 9x minus a 6. Next, it goes minus, and now substitute an a in place of x. So this is going to be a squared plus 9a minus 6. A squared plus 9a minus 6. And the whole thing is divided by x minus a. Then I need to do some algebra. So when I distribute, this is going to become a negative x squared. And I'm just going to take that negative x squared and put it close to this because both of them have squares. So for that reason, they're sort of similar. So I'm going to end up using what's called factor by grouping. So I'm going to group the squares together. So there's a positive x squared and then minus this a squared. Then this has a 9 and this has a 9. So I'm going to put those close to each other. So next there's plus a 9x and then minus a 9a. And these 6's are actually going to cancel because this is a negative 6 and then this is negative makes positive 6. And so they even deserve to see the red pen. Cancel them out. And then we have just a couple more steps of algebra. So this is the factor by grouping part. So you group these together and you factor them. You group these together and you factor them. Well, the first one, x squared minus a squared, that's the difference of squares. So that can be factored as x minus a times x plus a. And with these two in this red circle, I can factor out a 9. So there's still going to be this plus sign. And then factor out a 9, and it's going to leave x minus a. And then it turns out there's an x minus a here, and an x minus a here, and an x minus a here. That means that they can all get canceled. You get canceled, and you get canceled, and you get canceled, and you get canceled. And now the x can become an a. So since x is becoming an a, that means x and a are the same thing. So I could either put a plus a, or I could put x plus x. Since right here it says your variable should be x, I'm going to have it say x plus x. So it's going to say x plus 9. Or in other words, 2x plus 9. And then that is the derivative. After that, they say plug in numbers like 1. So that means the derivative when you plug in 1 is just 2 times 1 plus 9. 11. Stuff like that. Next, you'd plug in the 2, etc. But we did the fun part. And I seem to have 2 more pages. Oh, I also want to point out, I don't know if I've mentioned before, but that as you go through this homework, they will throw in review questions. Like every once in a while, they'll just be, hey, if you have x to the negative 11, that equals 1 over what? And so that equals this. So they'll just throw in some algebra review problems every once in a while. So this one is saying that we have this function, x squared plus x, and they're measured in meters per second, meters and seconds. Find the average rate of change as it goes from 1 to 3. So in other words, that's saying substitute the 3 first of all, minus, when you substitute the 1, and then divided by 3 minus 1. So if you get a calculator, and if I first substitute 3 into this, that's going to be 3 squared plus 3, that's a 12. Then substitute a 1 into that function, so 1 squared plus 1, that's a 2. And on the bottom, I don't even have to use a calculator. Check this out, 3 minus 1 is 2. And then on the top, that's going to be 10, and 10 divided by 2 is 5. So that's the average velocity. And then they say do the same thing from 1 to 1 plus h. So this would become the 1 plus h, this would become the 1, this would become the 1 plus h, and then that's still the 1. So let me just get a nice new piece of paper. It's actually probably the exact same age as this piece of paper, but I mean a blank piece of paper. So this has to be this is replacing the 3. So it's going to be f of 1 plus h minus f of the 1, and then divided by this becomes the 1 plus h, and then minus the 1. And again, we're using the function x squared plus x. Then I could use just this piece. So I need to take the 1 plus h and substitute it in for these x's. So that's going to say 1 plus h is squared plus, replace this x with 1 plus h, and then minus, when you substitute a 1 into this function, this is going to be 1 squared plus 1. So 1 plus 1 is going to be a 2. So this part's going to be a 2. And on the bottom, I can use my red pen to say a negative 1 and a positive 1 cancel. The only thing left on the bottom is the letter h. And this is again one of those situations where you have a binomial squared. So I'd like to use the shortcut, which means you square the 1, which is 1 times 1 is 1. Multiply these two, 1 times h will just be h, and then double the result. So that's going to be 2h. And then square the h. Okay, that part's done. Over here, there is a 1 and a minus 2, so in total that's going to make minus 1. And then there's also going to be a plus h. And it's still divided by h. And next up, you're right, grab the red pen. These cancel. So what's left? There's 2h plus h, so there's 3h. And then every term has an h, so you can cancel an h here, you can cancel an h here, and you can cancel one of these h's, which still leaves this h. So that means that it's going to be 3 plus h. So find the average velocity. Yes, that's part B. We just finished part B. Find the instantaneous velocity. So that again is the derivative, and then you plug in a 1. So for, I think I could just fit it right here, part C, we've got the function x squared plus x, and then find the derivative using the power rule. So the derivative is going to be, so take the 2, bring it in front and multiply, and then subtract 1 from this, and that's going to leave an exponent of 1. So you could write a 1 or you don't have to. And the derivative of just an x is just a 1. On account of its exponent right now is a 1, so when you do the power rule, the 1 goes in front, and then you subtract 1 from the exponent. And this leaves x to the 0, which equals 1, so that means the answer is 1 times 1 is 1. And then plug in x equals 1. So the derivative, when I plug in a 1, is going to be 2 times 1 plus 1. That equals 2 plus 1 is 3. And there's just one other homework question that I want to go over, and that is all the way down to number 34. So in between number 12 and number 34, there's a lot of straightforward using the power rule. And this one also is the power rule, but I thought it would be good to do this one. So for this function, first of all, I could rewrite the cube root as x to the 1/3. And right now, I cannot do the power rule until the x is in the numerator. And to do that, you just change its exponent to be a negative. Okay, so now this one is set up and I can do the power rule. So you take the exponent, bring it in front and multiply, and then subtract 1. So this is going to be negative times negative, so the derivative is going to be positive 14. And then x to the, so right here I have a negative 1/3, so a negative 1/3, and then subtract 1, and then subtract 1, and then go to math and ask the calculator what fraction is that. And it says it's negative 4/3. Now, I don't know if they allow negative exponents, but I don't. So I'm going to rewrite this one without a negative exponent. So the 14 is fine. The 14 does not have a negative exponent, but the x has a negative exponent. So it needs to go to the denominator, and then it's got a positive exponent after that. And there it is.